Chapter 5, Section 6, Parallel and Perpendicular Lines. So one way to tell if lines are parallel is looking at the lines in slope-intercept form or point-slope form. You check the slopes, and if they're the same slope, if they're equal, then the lines are parallel. So you can see here that the slope is 3 in both equations, so the lines are parallel. Same in this example, -7, -7. The slopes are the same, so the lines are parallel. Now, if you have two lines that have the same slope and the same y-intercept, these lines aren't parallel. This would be an example of the same line. Sometimes they'll give it to you in two different forms, and when you get them both into slope-intercept form, you realize that they're both 3x plus 1. That means they're the same line. So make sure they don't have the same y-intercept. They should have different y-intercepts. This one was plus 0. The other one was plus 2. Here we have -4 and +3, but they have the same slope, so they're parallel to each other. Now, this word opposite reciprocal. Opposite reciprocal means, so if we have 7, this is the same thing as 7/1. Opposite reciprocal means you flip the fraction and you change it to the opposite sign. So it was positive, we're going to make it negative. Please make sure you do not set these equal. They're not equal to each other. 7 is equal to 7/1, but then we flip it. This is a completely different number, and we negate it. So the opposite reciprocal of -7. Well, -7 is the same thing as -7/1. The reciprocal of that would be 1/-7, but we're going to change the sign so it becomes a positive instead. -1/3, opposite means it's going to become positive. Reciprocal means we flip it. 3/1 is the same thing as saying 3. Now, the reason that we're talking about opposite reciprocals is because this is how we tell when lines are perpendicular. Lines are perpendicular when their slopes are opposite reciprocals of one another. The y-intercept does not matter. They could be the same, they could be different. But when the slopes are opposite reciprocals, so -1/3 and +3, +3/2 and -2/3, that means that the lines are perpendicular to one another. So both of these examples show perpendicular lines. Now let's say we had the equations y equals 1/3 x plus 1 and y equals 3x plus 2. These lines are not perpendicular. Yes, their slopes are reciprocals. We have the slope here is 1/3. The slope here is 3. They are reciprocals of one another, but they're not opposite. One of them has to be negative and one of them has to be positive, so these two lines are not perpendicular. This is a type of example that you may see on a test. What type of lines are these? Well, as long as they're in y equals mx plus b, as long as they're in slope-intercept form, it's easy to see what the slope is. So here the slope is 3, and here the slope is -1/3. They are perpendicular lines because their slopes are opposite reciprocals. Make sure you know how to explain your reasoning. Now in the next example, we don't know what the slope is here, and we don't know what the slope is here, because it's not in y equals mx plus b form, it's not in slope-intercept form, it's not in point-slope form, so we can't even find the slope from there. So we want to get them into that form. In order to do that for this example, we're going to add the 3 to both sides. So we get y equals, because that cancels, 2x plus 10. In the other example, we're going to divide both sides by 2. And here we get y equals, because this cancels, divide each term by the 2. So 4 divided by 2 is 2x. 1 divided by 2 is 1/2. We can see that the slopes are equal. They're the same exact. They're both positive 2, which means the lines are parallel. Because the slopes are equal. But the y-intercepts are different. That is important to have. The slopes are equal, but the y-intercepts are different. In our final example, we have it in y equals mx plus b form already. 6 and 1/6. Well, they are reciprocals, but they're not opposite reciprocals. If you were to graph them on your calculator, you would see eventually they are going to intersect, but they're not perpendicular, they're not parallel. These lines are just intersecting lines. Because the slopes are different, but they are not opposite reciprocals. So this is for the last example. When it's not parallel, it's not perpendicular, it's going to be intersecting. Our final examples, we have our first one here and our second one here. So write the equation of the following lines. For the first example, a line which passes through the point 215 and is parallel to y equals 4x minus 1. Well, if it's parallel, that means the slope is going to be the same. So that means m has to equal 4, and we want it to go through 215. Now you could do this a few different ways, and I'm going to show you both ways. But the first way, we have a point and we have the slope. So use the point-slope formula. Now it doesn't tell you how to write the equation, so you can just plug in y1, the slope, and x1, and this can be your final answer. It doesn't tell you it has to be in slope-intercept form. It just tells you to write the equation, so this can be your answer. The other way to solve this problem is to use slope-intercept form, because that's what most people are comfortable with, although point-slope in this case is easier. Plug in the slope that you want, which is 4. Plug in the point that you want, which is 215, and solve for b. So you got 15 equals 8 plus b. Subtract the 8. You get that b equals 7. So that means y equals 4x plus 7 would be your equation. Now, you can see that if we distributed the 4, we'd get y minus 15 equals 4x minus 8. When you add the 15 to the other side, you get y equals 4x plus 7. So you can change this into slope-intercept form as well. Now looking at the second example, a line which passes through the point 1015 and is perpendicular to y equals negative 5/6x minus 2. Well, if it's perpendicular, that means we want our slope to be the opposite reciprocal of that. Well, this is a negative, so we want to make it positive, and the reciprocal of 5/6 is 6 over 5. You can leave it as an improper fraction. Again, we have point and slope, so it would be easiest to use the point-slope formula. And again, it doesn't tell you what form it has to be in, so we can leave it in this form. So y minus the y-coordinate equals the slope that we want times x minus the x-coordinate. And that could be our final answer. Now, We can also, like I said, a lot of people get comfortable with slope-intercept and it's not being specific. We can also plug in the 6/5 for the slope, the 10 for the x value, the 15 for the y value, and solve for b. We get 15 equals 12 plus b. Subtract the 12 from both sides means that b equals 3. So our equation would be y equals 6/5x plus 3. And again, you can see if we distribute the 6/5 to both terms and then add the 15 to the other side, we would get the same equation. Finally, one last thing I want to mention because I see this mistake made a lot on tests. Let's say you're given a point and the slope, and it's asking you to write it in point-slope form. We would plug in -15 for the y, so y minus -15, and -10 for the x, so x minus -10. So we have our y1 and our x1 plugged in. This is the same thing as saying y plus 15 equals -1/2 times x plus 10, because we can keep the sign of the first, change it to addition, change it to a positive. Same thing, keep, change over here. If you're given this equation and they ask you what point this is going through, or you're supposed to be plotting the point, make sure you know that the formula has minus signs. So if this is ever a plus, that means that that coordinate is negative. So it should be -10, -15 that you're starting with.